So, a very good morning to all of you. Today, we are going to learn a very important topic of this course, AGB 605, uh, in which the matrix is one of the important and interesting chapter. We have in earlier classes seen about the introduction of matrix, applications of matrix, determinant of matrix, and primary operations of matrix. So now a very essential aspect of matrix, that is a inverse of matrix, that we are going to learn in this class. So we have a two objective. First of all, to understand the concept of inverse of matrix, and another is to know the methods of inverse of matrix. So no doubt in our practical class, we are going to learn one by one all these methods, but let us have an introduction theoretically about the various methods of inverse of matrix we are going to learn with these objectives. In a very simple way, looking toward the introduction of this concept, inverse of matrix is another matrix which is when multiplied with the original matrix gives us an identity matrix. Now you are very much aware about the identity matrix, where the diagonal elements are 1 and other upper and lower diagonal elements are 0. So we used to call it as a unit matrix, identity matrix. So likewise, here we are going to determine such a matrix which is when multiplied with the our original matrix, it gives a identity matrix. So here we can say that the inverse of a matrix is denoted by a superscript -1. Now you are aware about the mathematical concept of inverse. So for example, inverse of 2, we used to say it as an 2 raised to -1. Likewise, here, if suppose there is a matrix A, then the A into A inverse or A inverse into A, the product of a original matrix with multiplication of its inverse matrix, we will get an identity matrix. So this is the concept of inverse of matrix, and the prerequisite of this determination of inverse of matrix is that the matrix must be square to have an inverse of matrix. Means, for example, 2 by 2 or 3 by 3. So this will be the situation only when we'll have a inverse of matrix. But here again, not the inverse of matrix will not be possible for all the matrices, square matrices. Then regarding the concept, we can understand here. For example, let A is a square matrix. Now we know that the square matrix, how we are indicating in a square cut bracket. So if there is a matrix square matrix A, and suppose there is another matrix B which is the same size, so then B, the square matrix B multiplied by square matrix A, if suppose it is an identity matrix, then we can say that B is the inverse of matrix square matrix A. So here we can say that here the original matrix A is to be called as invertible or non-singular. So when we are having such a matrix which when we multiply it, we are getting the identity matrix, then the original matrix is known as invertible or non-singular. If A inverse does not exist, then it is known as non-invertible or singular. Now here we can say that both the A and B square matrices, which are having n by n dimensions, means 2 by 2 or 3 by 3 or 4 by 4, then with respect to the inverse of matrix, below statements are considered to be true, and this is but obvious whatever mathematical concept or the rule we have learned throughout our algebra that are depicted here. For example, the square matrix B is the inverse of A and A is the inverse of B, then we can say that both A and B are invertible, or these are non-singular, which we have already discussed in our first second line. then here we can say that all the columns of matrix A or matrix B, these are linearly independent, or even all the rows of both the matrix are linearly independent. So this is just a theoretical concept about the matrix inverse. Now let us see what are the methods of matrix inversion. Okay, so there are major 5 methods of matrix inversion. First is elementary transformation. Second, elimination procedure. Third is adjoint method. Fourth is Doolittle method. And fifth is pivotal condensation method. All these methods are easier as compared to, and both, all the methods have their own advantages. So let us see one by one what is the concept of each and every method. For example, a very first method is elementary transformation. So as the name is suggesting, elementary transformation, here what we are doing in this method, a suitable row or column transformation related matrix, in the related matrix, for example A, on the left hand side, we are going to earn or derive another matrix on right hand side, which will be a identity matrix. For example, here let B is the inverse of matrix A, then we can say that the inverse of matrix B and multiplication of original matrix, this will form the identity of matrix, isn't it? So here the inverse sign has to be left. The A is the multiplication of identity matrix into inverse matrix. So let us see a suitable example here. For example, we know that this is the algebraic equation. For example, here the AX is equals to B. If suppose this is the equation, then we know that what we are doing in general way, A into X is equals to B. So to determine the value of X, we are going to transform this equation as the X is equals to B upon A. So upon A, it means that we are taking the inverse of A. So automatically the value of X will be estimated as inverse of A into B, isn't it? So likewise, if suppose there is a matrix A, which is 3 by 3 dimension matrix, then here we can, by analogizing this equation, we can consider that the matrix A into this X means these are the whatever we have to estimate the value, X1, X2, X3. As we know that this is the only the thing when we can determine the solution matrix. So X1, X2, X3, this is nothing but the elements of the inverse matrix, and here the solution is B1, B2, B3, which is supposed to be an identity matrix, isn't it? So now here we can transform this equation in a binomial form. Here we are going to multiply the each and every element, just like a scalar multiplication of two matrices. We can have x1 plus twice x2 plus twice x3. This is going to derive the value b1. Likewise, 1 into x1, that is x1, plus 0 into x2 is going to be 0, and x3 into 1. So we can say that x1 plus x3, it is the value b2. Likewise, x1 plus twice x2 plus x3, so this is the value of b3. Are you getting this? What we have done? We have transformed the equation into binomial form, and now we have three equations: equation A, equation B, and equation C. Now we know that in our 12th or below, we can say in a 10th standard, we have solved such many equations. And what? For determining the value of x1 or x2 or x3. Once we got the, for example, in this equation B, if suppose you are knowing the value of x1 or x3, you can find out the alternate value. Likewise, in this elimination method, elimination procedure, we are eliminating, or we are calculating the value of x1, x2 and x3, so that we can have the solution. X1, x2, x3, it is nothing but the inverse of original matrix into this scalar matrix b1, b2, b3. So this is just a theoretical aspect. We are going to learn in detail while calculation part is considered in a practical class. So now second method is the adjoint method. Adjoint method is nothing but a adjoint matrix. We have to consider the adjoint matrix, and this adjoint matrix is the transpose of matrix of cofactors. It is what adjoint matrix means. It is the transpose of matrix of cofactor. Now here, first of all, we'll focus on this word transpose of matrix, that we are able to understand. By interchanging the rows or columns, we can have a transpose of any matrix. Now here, the another word is a cofactor, that we are going to learn. If suppose you are able to estimate the cofactor, and if suppose you have a matrix of cofactor, then by transposing the matrix of cofactor, we can have an adjoint matrix, isn't it? So likewise, what we are doing, we are obtaining the adjoint method, or we are estimating the inverse of any matrix by replacing each element of matrix with its cofactor. Now, how it has to be done? We have to follow several steps for estimating the inverse matrix by this adjoint method. So let us see one by one. I have short abbreviated it as a MCTDI just to memorize it. M stand for minor matrix. First of all, we'll have to consider the what do you mean by minor matrix. Then C stand for cofactor. We'll have to estimate the cofactor. Third is T. T is a transpose of cofactor matrix that we have already discussed in a first line to estimate the adjoint of a matrix. Then the next is D, that is the calculation of determinant of original matrix. And fifth is the inversion by formulae. So here, if we consider each step independently, then we can go with the inversion of a matrix. So let us see one by one what is meant by minor matrix, what is meant by cofactor, how we are gaining the adjoint of matrix, how we are determining or estimating the determinant of matrix, and how we are calculating the inversion by formula. So first of all, calculation of a minor matrix. Now, this is not a new term to you, I think, because for any elements in a row or column, we have yesterday only, while determining the determinant of matrix, we have considered this. Whenever we are considering any element, we are estimating the minor matrix in form of, one second please, if there is any admission of any student. So I think Anup and the Mukund have not been present here. Okay, no problem. So let us consider calculation of minor matrix. So calculation of a minor matrix. Here we know that, for example, for the first element 1, how we are going to estimate the minor? We are excluding the other elements in a row and column of this 1. So we'll have this square matrix 0, 1 and 2, 1. Likewise, we can estimate the minor matrix, isn't it? For say, for example, for element 1, 3. 1, 3 element means 1 first row and third column, the value is 2. So we'll exclude the Okay. So we can estimate the minor matrix, isn't it? For example, first for the element first row and third column, the element is 2. So we can exclude the other elements in a first row and third column, and whatever left over is a minor matrix. We can multiply the diagonal members elements and estimate the minor matrix value of this minor matrix, isn't it? Then, say for example, the second step is calculation of cofactor. Cofactor, the formula for cofactor is nothing minus 1 into this I plus j. We know that I plus j, it is the position of row and column. I is a number of ith row or the number of row, and j is the number of column. And we are going to multiply it with the minor matrix. Now here the sign is decided by this minus 1 into I plus j. For example, say for example here, the element 1 1 is considered. 1 1 is first row and first column. So here for the first row and first column, I plus j, it will be 2, isn't it? 1 plus 1 will be 2. 2 into multiplied by minus 1. So this will be the minus 2. So this is the way how we are estimating the cofactor. So now, if suppose the second element is considered, 1 2 means first row and second column, so value is 2, the minor matrix will be 0, and cofactor will be minus 1 into 1 plus 2. So 3 into minus 1, that is 3, but the cofactor is minor matrix is 0, so whole value will be 0. So likewise, we are going to estimate the cofactor. Okay. Then the third step is transpose of a cofactor matrix. So now here you can understand, for every element we can estimate the cofactor and its minor matrix. We can have multiplication of cofactor as well as minor matrix. Then whatever the product matrix has been received, we can say that matrix has to be transposed. So whenever we are transposing the matrix, the transpose of matrix is denoted by A prime. A prime is nothing but the transpose matrix of A, or we can indicate by putting the superscript T or capital T. So A raised to T or A raised to capital T, this is the transpose of original matrix A. So now, say for example, if we have a matrix this A, which is consisting of these elements 1 2 2 1 0 1 1 2 1, the A prime or A transpose matrix is just alteration in the rows and columns. Those whatever were the rows, they will be the element of column. Those were having the columns, that will be automatically become row. So this is the third step in adjoint method, to transpose the cofactor matrix. Whatever cofactor matrix we have received, we are going to transpose the cofactor matrix. Now the transpose of cofactor matrix, it is known as adjoint of the matrix. It is known as adjoint of the matrix. Now the fourth step is that calculation of determinant of original matrix. Now this is a we have already covered in earlier class, that how to estimate the determinant of any matrix, so that we can estimate. And the fifth step is that calculation of inversion by formula. So A inverse or inverse matrix formula, it is given as 1 upon determinant of A into adjoint of that matrix. Now you can remember all the elements. This determinant of A, which has been estimated in our fourth step, adjoint of A, that is estimated in a third step. For receiving the adjoint matrix, we have estimated the cofactor and minor matrix, which were covered in first and second step, isn't it? So likewise, we can estimate the inverse of matrix by cofactor by this adjoint method. Then the next method is the Doolittle method. In this method, and this is very much useful when we are calculating the correlation along with the regression coefficient. So in case of partial or multiple correlation, we can estimate the this inverse of matrix. So where it is used in case of poultry breeding problems, where a correlation matrix is taken on the left hand side and unit matrix has to be taken on right hand side. So we are going to adjust one by one element, so that whatever unit matrix we have kept in our right hand side and the correlation matrix mentioned in the left hand side, we are going to transform the left hand side to the unit matrix. For say for example, here this is a design of a Doolittle method, where we have kept here the left hand side, this is a raw matrix, and on the right hand side we have kept the inverse matrix, unit matrix 1. So how to calculate that we are going to cover in our practical class. But here what we are going to do, we are transforming this left hand side matrix to the this type of unit matrix. So automatically in whatever changes happen in the inverse matrix or on the right hand side, that are going to give us a inverse of the matrix. Okay. Then it is a next method is a pivotal condensation method. In this method, we are going to condense the element along with their inverse, and it supplies the value required for the transformation of raw data. Here also, in the similar fashion, we are going to cover the Doolittle method. Means on right hand side, the raw matrix is there, and on on left hand side, our raw matrix is there, and on right hand side, unit matrix is there. So on the same fashion, we are going to transform or convert the left hand side matrix into unit matrix. So automatically the unit matrix present on the right hand side, this will become the inverse by some operation. So this is just a theoretical part of our inverse matrix, the types of inverse matrix. So now some properties of inverse of matrix, which we already we have discussed, how the inverse matrix, the inverse of any transpose is equals to the transpose of the inverse. This is nothing a new thing, that we will try to understand all these properties and principle by using a simple equation in our further classes. Inverse of a symmetric matrix is also a symmetric. Inverse matrix is a product of reverse product of inverses of factor. Now here you can understand A into B inverse is the product of B inverse into A inverse. For a diagonal matrix A in which the diagonal entries are non-zero, then the A inverse is again a diagonal matrix with entries 1 upon dii. So these are the nothing but the theoretical aspect. We are this will be easier to understand while solving the problem. If S is a block diagonal matrix, then the inverse matrix is also a block diagonal. Then the inverse of upper triangular matrix is an upper triangular matrix, and inverse of lower triangular is also an lower triangular matrix. These are nothing but the mathematical principles of about the inverse of matrix. We are not that much concerned about this aspect, but the thing is that we should be able to understand how we are going to determine the inverse of matrix. Now, one of the interesting application of this invert of matrix, this was done in ancient time, just to decipher the code language. When there was no telephones or such things, the from one party or one kingdom to another kingdom, or one king to another king, or some two big stalwart, some secret codes or messages were crypted, or it has kept hidden, so that were encrypted or that were deciphered with the help of this inverse matrix. So this is the some sort of an interesting application of this matrix. I have given one problem to find out the inverse of the matrix, where we have given three equations, and now with the help of very first elimination method, you can convert this into a simple matrix: 1 2 3 1 1 1 2 2 1. This will be the elements, and then multiplied by x, y, and z, and the B1, B2, B3 value will be minus 9, minus 8, and 10. So this you can, what we can say, estimate. So just let us revise, because I think Anup has been joined just now due to some technical difficulties. So today, friends, we have discussed about the concept of inverse of matrix, as well as we have been familiar with the methods of inverse of matrix. So now here, uh, what we have seen that inverse of matrix is another matrix, which is when multiplied with the original matrix, we are getting the identity matrix, isn't it? Just we are revising, just having a 5 to 10 minute time. Uh, so inverse matrix is any matrix which an original matrix is when multiplied, we are getting the a identity matrix, and it should be necessarily be a square matrix so that we can have a solution. Now, also we have seen how the inverse or the any two matrices which are giving the product as a identity matrix, then in such case both A and B matrices, we are calling them as a invertible or non-singular, isn't it? And in case when the does not exist, the inverse matrix does not exist, then we are calling it as a singular or invertible. And we know that when the both matrices A and B are non-singular or invertible, means there exists a unit matrix by multiplication of this thing. Then we can say that the columns and the rows are linearly independent. This was a just theoretical part. Then we have seen the 5 different method, introduction of 5 different method about the matrix inversion: elementary transformation, elimination procedure, adjoint method, Doolittle method, and pivotal condensation method. In elementary transformation, what we are doing, we are simply estimating the inverse matrix B by considering the multiplication of the A and A inverse, isn't it? So this was the elementary transformation method. Another was elimination procedure, where we were trying to estimate the value of x1, x2, and x3 by transforming the our original matrix and their solution. So I have given the assignment by solve for solution by elimination procedure. You can follow this procedure and you can try to estimate it. So here we are getting the value of B1, B2, B3. If we are knowing the value of B1, B2, B3, then we can estimate the value of x1, x2, x3. So this is the case. Then in a third method of adjoint method, we know that adjoint matrix is nothing but the transpose of cofactor matrix. And for that we have followed 5 different steps, where first of all we could estimate the minor matrix that we have already covered during the determination chapter or lecture, how to estimate the minor matrix. Then again, how to calculate the cofactor. So we know that it is nothing but dependent upon the what we can say, cofactor is dependent upon the position of particular element in a row and column, because this I and j indicate the number of row and number of column. So depending upon the position, we can have a this kind of cofactor. Then by arranging all this cofactor, we can transpose the cofactor matrix, which is well known as a adjoint of that matrix. Then by using this formula, A inverse or inverse of any matrix, 1 upon determinant of A, we can estimate the determinant of any matrix. And then by multiplying the inverse of the determinant with the adjoint, we can have a solution of inversion. Then in next Doolittle method, which is generally applied in case of correlation and regression coefficient, where we are keeping the correlation matrix on the left hand side, and on the right hand side there is a unit matrix. And what we are doing, we are transforming some changes, some calculations, so that our left hand side matrix, which is a correlation matrix, that will convert in a unit matrix. So accordingly, whatever changes happen in the unit matrix, this is nothing but the value of a inverse matrix. So this is somewhat design of inverse matrix. and all these methods we are going to learn in our practical class. So don't worry about it, don't bother about it. Then pivotal condensation method. So in this method, what we are doing, we are condensing the elements uh, to find out the inverse. And in the same fashion as mentioned in earlier method of Doolittle, we are keeping the we are keeping the original matrix on left hand side and unit matrix on right hand side, and we are following some operations so that we can have a unit matrix on the left hand side. So afterward we have seen some properties. So I hope you will try to estimate the value of x, y, and z by solving this by elimination procedure. Just for sake of information or just for the interest, you can go with the estimation of this method. So I hope this is the lecture about the different methods of what we can say estimation of how to estimate the inverse matrix and just the concept about the inverse of matrix. So I hope very hurriedly due to lack of time by this online mode, we have covered this topic, but I have given in our practical manual about this. So I hope you will go through it. I will share the what we can say literature about it, PPT and the recording also. I think Mukund could not join today due to network error. So no problem. And again, if you have some difficulty regarding today's lecture, so you can please mention. So Mrunal, is there any difficulty for you considering today's lecture?
नो सर, बट खूप असं कन्फ्युजिंग वाटत आहे.
Okay.
मेथड्स वगैरे.
Okay. Rosa, do you have any difficulty?
Yes, sir.
Huh?
No, sir.
Yes, sir,
No,
and no, sir. Okay. So difficulty, I don't got it. What difficulty you have? I think Anup has been joined very late, so he may suffer from so many difficulties because this is not a simple talk of inverse. This inverse of matrix. This was a difficult concept, but don't bother about it. We'll have a approach of solving inverse of matrix one by one in our practical session. Okay, I'm trying to record the calculation part by videographing myself. If suppose it happens, if suppose it works, then I will share that. No need to bother about it. But my intention was to make you familiar about the concept of inverse of matrix. The basic fundamental is inverse of matrix is such a matrix which is multiplied with the original matrix will have a product as a unit matrix. So this is a bottom line of this class. So Anup, I think you should go through the video recorded and the theoretical aspect covered in our practical manual also. I suppose you are doing your assignment regularly, because one day we'll have